Hey guys, today we're talking about circles and ellipses. So this should be a review of some of your conic sections and something you may have seen in geometry as well. But we want to know, how do I write the equation of a circle or ellipse in rectangular form? And rectangular is the form that we're used to. We're going to see a new form in the coming days, so that's why that says that. Okay, so the first thing that you need to know are the standard forms of our types of equations. So the first one that we're going to look at is a circle. And so a circle has a standard form of x minus h quantity squared plus y minus k quantity squared equals r squared. And all those things mean pretty much what they've always meant. Your center is going to be at hk, so remember that it's going to be opposite of the sign that you see there. And then your radius is just going to be r. So you take the square root of the thing that's by itself. Okay. Now an ellipse is a little bit more tricky. And this is what the standard form of an ellipse looks like. We have x minus h quantity squared all over a squared plus y minus k squared all over b squared equals to 1. And so the difference here is that you have equals to 1 and you're going to have denominators that are different. Okay, if your circle didn't have, if it said equal to 1, it would have r squared under the bottom. So if I look at this guy, we still have a center. Oh, hey. Okay, anyway, we still have a center at h comma k. But the thing that changes about the ellipse is, remember, it's like a squished circle. And so your a value is going to tell you your x-axis radius. So basically it's telling you along your x-axis how far out to go. Whereas b is going to tell you that y-axis radius. So calling it a radius is a little bit tricky there, but I'm just thinking about, that's how far I go out on the x-axis, that's how far I go out on the y-axis. And so these are your standard forms of these types of equations. So let's first start with a circle. It says graph the equation and label the center and the radius. So the first thing I see here is x squared plus y squared minus 169 equals 0. Now the thing about the general form that we saw before is that it didn't have equals 0, it said equals r squared. So you have to make sure you move everything over so you have x and y by itself. So I could add 169 to both sides. And now this looks like the standard form equation that I saw before. And so if there is nothing going on in parentheses with your square, that means that your center is going to be at the origin at 0, 0. I'm adding and subtracting nothing into those two expressions. Now your radius is just going to be the square root of that number that's all over by itself. And this one happens to be a nice one, that's equal to 13. So I know when I draw my picture, and I'm going to make a disclaimer right now that this is not going to be very circly. I know that on my picture I'm going to go out 13 in every direction from my center. So since my center is at the origin, that makes it really easy. I just get to go 13 all the way around. And I'm not even going to count because that would take me too long. Then you're just going to connect your dots, trying really hard to connect them, and hey, it looks pretty circly. Okay, I will never judge your drawing ability of circles. Now this guy over here, number 2, looks a little bit different. It is already in standard form, which is nice, but now your center is going to be changed, because right here, and I hope that's a 3, right here this has a plus something in there. So remember, you always go opposite of what that is. So I'm going to say negative 3 is going to be my x coordinate. And then this guy has a minus, so that means I do opposite, and it would be a positive 1 would be the center. This one's radius is the square root of 81, which is just 9. So when I go ahead and draw this, I'm going to start at my center. So I'm going to start at 1, 2, 3, up 1, and that's going to be my center. And again, your radius is going to tell you how far to go in any of the directions. So I know I need to go 9 out all the way around. So my picture is going to be kind of squished here, so I need to go 9 this way. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So my other point over here would be at 6, comma 1. Okay, and then I'm going to have to go 9 the other direction, and that would get me out here to negative 12. I'm not going to count that. I'm just going to subtract 9. Okay, and then I have to do the same thing up and down. So if I add 9 to my 1, that's going to put me at negative 3, comma 10. And then if I subtract that 9 down here, that would put me at negative 3, comma negative 8. And again, I just counted. I just was being lazy because I can't count that far in the space that I had. And then I just connect my dots, and this looks kind of ellipsy, but I tried and I labeled my points. Okay, so this again is going to be a circle because of the way that the equation is set up. Now, if I was given an equation that looks like this is going to be an ellipse. Okay, if you notice it equals to 1, there's a plus sign in here, and my denominators are both different. So we're going to graph the equation, say what the center is, and then tell me what the vertices are. So whenever I do these, my first step, of course, is to find the center. And this one's nice. There's nothing by the x or the y, so it's just 0, 0. The next thing I'm going to do is I'm going to label my a. So if this is a squared down here, so if a squared is 25, a must be 5. I'm going to label my b again. B squared is 4, so b must be 2. So then when I go ahead and I draw this, it makes my life a little bit easier because I know all the pieces. So I know I'm going to start in the middle, and my x-axis radius, how far I go on my x-axis is 5. So I'm going to go 1, 2, 3, 4, 5. And that's going to be one of my vertices, one of the places that my graph ends. Then I'm also going to go the negative direction, 5. Okay, and that's my x radius. Now I'm going to go my y radius, and that's only up 2. So I'm going to go up 2, and I'm going to go down 2. And then I'm just going to connect my dots. So I know that all my, well, I didn't draw a dot down there, struggle. And I know that my vertices then, I can label them. This guy right here is at 5, 0, and I also have negative 5, 0. So I'm going to go ahead and just write plus or minus out of laziness. And then I went 0 and then plus or minus 2 for my other ones. So these are my vertices. Okay, and again, when you're not centered at the origin, it gets a little bit more tricky. So I'm going to put my center down. I know my center here, remember it's opposite, so it'd be -1, comma, -6. Again, you just look for your x and your y's. And then again, I'm going to label my a and my b. Square root of 1 is 1. Square root of 36 is 6. So now I can go ahead and graph this thing. Oh good, it will be a tall one. So I go ahead and I put my center in, except for I didn't draw this well. Here, let me fix that. Okay, so since I know my center is at -1, -6, I'm going to kind of keep myself down here in quadrant 3. So I'm going to go -1 and then 1, 2, 3, 4, 5, 6, and that's my center. And then again, I'm going to count each direction this number right here. So a is my x. So I get to go over 1 for each of these guys. And so that point is at 0, -6. And this point over here is at -1, -6. Or -2, -6, sorry. Can't count apparently. And then in my y direction, I'm just going to go up and down 6. So I'm going to go 1, 2, 3, 4, 5, 6, which happens to be nice and at the origin, or not origin, but on the axis. And then again, I'm going to go down 6, which I'm a little bit lazy, but I know that that would be at -1, -12. I just subtracted. And then I draw this guy. And so this guy has a vertical major axis, so it's a long, skinny one, and hopefully yours looks a little nicer than mine. Okay, but that's how you graph these guys. The last thing we want to look at is if we're given a graph, how do we go ahead and write the equation for it? So the hardest part about these, I think, is finding the center, because most of them are not going to be centered on the origin. So something that might help you out for these is that always, 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 the center is the midpoint of both diameters. So even if it's an ellipse, if you can find the diameter of the vertical side and the horizontal side and find where they intersect in the middle, that's going to go ahead and be your center point. So if I look here, I want to figure out where these two guys, and this is a circle, in case you couldn't tell, and I want to find that center point because that's one of the main points of my equation. And so one of the other things to notice here is your y values repeat on these sides and your x values repeat on these sides, and that's going to be your center point. So -1 is going to be my x coordinate, and -2 is going to be my y coordinate. So my center here is -1, -2. And once you find your center, it's really easy to find your radius then, because then you know to get from -1 to +4, that means that I went over 5 units. And you can count in any of the directions. -2 down to -7 is 5, etc., etc. So I then know that my radius, or my r, is 5. So now when I go ahead and I write this into my equation, remember we always put x minus h, so since this is a negative, I'm going to write +1 squared plus y, again I have to change the sign, 2 squared, and then don't forget you're going to square your radius, so it's not just 5, it's 5 squared, or 25. Okay, I'm going to go ahead, and if I want to find an ellipse, I do the same process here. I want to find my midpoint of my two diameters, and that's going to happen to, whoa, hello, it's going to be here at -2, 1. And again, you can just look at your x and y coordinates to figure that out, or you could actually physically go through and find the midpoint by using the midpoint formula. So my center here is at -2, 1. Okay, the next part is to figure out what my A and my B are. And remember, A goes with your x-axis. Okay, A is always on your x-axis for an ellipse. And so I can just count and see how far over I went for my horizontal radius. So I went from -2 to 1, so that's 3. So my A is 3. And then I went on a different color. This one I haven't used yet. And then from here, I went from 1 to 2, which is just 1. So my B, or my y-axis, is just 1. So now I'm going to plug in all those pieces into that formula. So I'm going to have quantity x, change your sign, +2 squared, and then that's going to go all over a squared. And a is 3, so a squared is 9, plus y. Remember, you change your sign, -1 squared, all over 1 squared is 1, so you could just leave that off if you wanted to, and it's going to equal to 1. So hopefully that was a good review for you, and you remember how to do circles and ellipses.